All right, so today I'll try to tell you about generative flow networks, or GFlowNets, at a high level. So let's say you're trying to generate a molecule. One way to think of a molecule is it's a kind of assemblage of Lego blocks, right? So you might have different fragments that are kind of Legos, and you're attaching them together. And then maybe you pass this to another machine learning model, and this machine learning model says, "Oh yeah, this is a pretty good molecule, so I'm going to give it a reward of 11." And maybe you generate a new molecule in your machine learning model. You place this by this other Lego block, and you get a different reward. Maybe it's less good, so now you get a 9. So the way that the GFlowNet framework tries to understand this process is by saying the process of generating each of these molecules in the computer is just a sequential process, right? So you start with like nothing, and then you take the action of adding this A Lego block, and then maybe you take the action of adding the B Lego block, right? So now you're at the state where you have this AB molecule. But you could have done, maybe added a C or something, right? So you can do that over and over. And you can think of this as an agent kind of generating a molecule. And once in a while, the agent is going to say, oh, I've generated, something like this, or maybe this A, C, B compound. And it's going to say, I'm done, right? So time to stop. And it's going to get some reward. So the idea behind this generative flow network framework is to say, well, this entire graph of generation can be understood as a flow network, right? So if this reward here is 9, then we're going to say there's 9 units of flow that emanate from this state, this terminal state here, and go back to the original I have nothing state, right? This is S0. And in particular, the way we train these models is to explore the states, right? Generate some molecules and get some rewards, and then backpropagate the flow implicitly through a model, right? So what would a model look like? Maybe it's a graph neural network and it's trained on these graphs. And its job is to say, well, if I'm seeing AC, there's a couple of different actions that I can take. And these actions have different potential flows. And the way that you train these models to say, okay, well, learn to predict that if you take this action and you stop, the flow is going to be 9. Maybe if you explore some other branch, there's a bunch of molecules here, for example, that have a bunch of rewards. So maybe the flow for this edge is like 1,000 because it's very promising. And then the way you use the flow that you learn is that you sample actions, so like choosing the next Lego block, in proportion to how much flow there is. And the reason when we discovered this framework, we thought this was really cool, is because doing that has a really interesting property. If you train a model for forever, right, at convergence, you're guaranteed that if you start from the origin and you start sampling, adding Lego blocks to your molecule, and you go all the way to the end, then you're going to end up sampling objects with probability proportional to their reward. And this has some quite magical properties, right? In particular, it kind of guarantees that you'll cover the entire state space, of course, given enough time. And that makes it so that kind of by construction, by design, GFlowNets end up being really diverse, right? They are trained to kind of model the entire distribution of rewards in a state space. And that desire to model everything, and especially to model places where there is reward, where there are interesting things, makes them naturally want to explore the whole state space. So that's GFlowNets in like 2 minutes.